Solve problem on crashing by time cost trade-off method with dummy activity.
Let us understand the given data. Activities A, B, C, D up to G are mentioned in the question. Predecessors are also mentioned. Normal time, normal cost, crash time and crash cost. This is the given data in the question. Now what is the first step? So first step is to draw the network diagram. Now if we observe two activities A and B having no any predecessor. So we will start these two activities from the node 1. So I will draw here the node 1 and from this there are two activities. Here this activity A and here this activity B. So we have to show these activities with the help of arrow. Now next step, here C, D, E, these are the activities which is having common predecessor as a B. So here the B ends at this node, we have to start these three activities, that is C, D, E. So we will draw here three arrows. So here this C, this is for the D and this is for E. So we will show here arrow C, D, E. Now next activity F, which is having predecessor E. So activity E ends at this node and then only activity F is getting started. So we will show here activity F. Now we will give numbers to these nodes later. Now next activity G. Now for this activity there are three predecessors, activity A, activity C and activity D. Now if we observe these two activities, that is activity C and D is having common starting node and these two activities merged at the same node here from where this activity G starts. So there is the rule, that is no any two or more than two activities started from the same node or event and getting merged in the same node or event. And when these two activities are merged in the same node or event, then we have to show here the dummy activity. So how to show the dummy activity? With the help of arrow. So I will show here. So first I will merge these two activity A and C, because A is having starting node and C is also having starting node. So these two are the nodes are different nodes. So we can merge here these two activities. So we have to extend the arrows. So for A also we have to draw here the straight line. Now what about the activity D? So I will show here is the end for the activity D. And now from this node we will show one dummy activity. So dummy activity we have to show with this dash line. We have to show arrow and this is the dummy activity 1. So we will give here the D1. Now next is activity G. So activity G is getting started from this node. So I will show here activity G. So we will show arrow also. Now the arrows from this G and F are open. So for these two activities are open. So we have to close this arrow with node. So this is the end node. Now we will give the numbering to these nodes. So first is here. So second node will be here. Then the third node I will give here. Then after 3, this is the fourth node where all these three activities are merged. Then here is the fifth node and then last one, this is the end node, that is the sixth node. Now we have to show the normal time as well as crash time for each activity in the diagram. So how to show? So normal time is 10 and crash time is 7 for activity A. So how to show? So we will show 10 and we will show crash time in the bracket. In the same way for B, 8 and 6. So I will show 8 and 6. For C, 5 and 4. 5 in the bracket 4. D, 6 and 4. 6 in the bracket 4. Then E, 8, 5. Then F, 5, 4. So 5 in the bracket 4. And G, 12, 8. So 12 in the bracket 8. So this diagram is getting completed. Now we have to calculate the cost of reduction. So we have formula. So it is also known as the cost slope, and we have formula crash cost minus normal cost divided by normal time minus crash time. So we will first try for this activity A. So crash cost 30,000 minus normal cost 20,000 divided by normal time minus crash time 10 minus 7. So we have to make calculation and we have to fill here the value. So in the same way we will apply the same formula for the other activities and we will calculate here the cost of reduction. There is one more step, that is for the normal cost we have to make here as a total. So when we add this 20,000 plus 15,000 plus 8,000 plus 11,000 plus 9,000 plus 5,000 plus 3,000, then this addition, that is equal to 71,000. So this normal cost remains constant during the crashing process. This is the calculated cost of reduction for different activities. In question, indirect cost is also mentioned rupees 2,800 per week. Now we will prepare here the first table, various possible path, normal time and shortest time. So we will fill up this first table with the help of the diagram. So how to find out the various possible path? So for that, this path should be start from this node 1 and end to the node 6, that is the end node. So first path, if we observe 1, 4, 6, that is activity A and G are involved. So I will write here A to G. Now we will calculate the normal time. So here 10 plus 12, that is 22. Then 7 plus 8, that is 50. Now next 1, 2, 4, 6. Now in this, which activities are involved? B, C, G. So I will write here B, C, G. Now we will calculate the normal time. 8 plus 5, 13, 13 plus 12, that is 25. Now we will calculate the shortest time. 6 plus 4, 10, 10 plus 8, 18. Now we will move to the next path. So next path is 1, 2, 3, 4, 6. Now 3 to 4 there is dummy activity. So we will not consider this. So in this there are which activities are involved? B, D, G. So I will write here B, D, G. Because this dummy activity is nothing but it is dummy activity for D. So we have considered D here. Now we will calculate the normal time. 8 plus 6 plus 12. So here 6 plus 8, 14 plus 12, that is 26. Now we will calculate the shortest time. 6 plus 4, 10, 10 plus 8, 18. Now we will move for the next 1, 2, 5, 6. So in this there are three activities B, E, F. Now we will calculate normal time. 8 plus 8, 16. 16 plus 5, that is 21. Now we will calculate shortest time. 6 plus 5 plus 4, that is 6 plus 4, 10 plus 5, 15. So this table is completed with reference to this diagram. Now second table is crashing and here is the cumulative, that we have to calculate the cumulative cost. And third table is for the cost sheet, that is known as cost sheet. Now in cost sheet table there is the first column, number of weeks. Now how to know that the process of crashing. So which number of weeks that we have to refer. So if we observe, we have to find out which is the maximum normal time. So maximum normal time is 26. So I will make here bracket. And what is the maximum shortest time? So maximum value is 18. Now if we observe, we can crash the project time, or we can say we can reduce the project time from 26 number of weeks up to the 18 number of weeks. So we have to write these values in the number of weeks in the descending order. So how to write? So first should be 26, then 25, then 24, 23, 22, 21, 20, 19, and last one is 18. So we can reduce the project time from 26 to 18 weeks, but at the same time we have to find out the total cost by considering this normal cost, crash cost and indirect cost. And then we have to find out for which number of weeks there is the minimum cost. So how to find out? So first, if we complete the project in 26 weeks, then there is no any crash cost because we have not reduced any number of weeks. So normal cost that we have calculated, that is 71,000, and that was the total normal cost. So we have to keep this constant. Now here total cost, that is 71,000 because no any crash cost. What is the indirect cost? So indirect cost 2,800 for 1 week. So we will calculate here 2,800 multiplied by 26. That is 72,800. So how to take the total cost? That is this total cost plus this indirect cost. That means here we have to take the final answer. So I will add these two values. 1,43,800. This is the final value. Now we will move next. So next we have to start for the crashing. So which activity that we have to take first? So if we observe, we have to take the first activity for crashing, for which having normal time maximum. So normal time is 22, 25, 26, 21. So we will refer or we will select this BDG because BDG is having maximum normal time. So for crashing, here first activity will be BDG. Now how to crash? So for that we have to make the 4 number of changes. So 4 number of changes. First change will be here, second change in the diagram, third change we have to calculate this cumulative cost, and then we have to mention this crash cost in this cost sheet table. Now for crashing there are 3 activities available. First activity B, second D and third G. Now we will refer the cost of reduction. So B is having 25,000, D is having 2,000 and G is having 250 rupees only. So if we select activity G, then there is the minimum cost. So here we will mention the cumulative cost because this is the first cost, so no any cumulative cost. The cost of reduction for activity G. So I will underline this activity G here, or I will mark for this activity G because I have selected this activity G. So it is 250 only. So this is the first change. Second change, for this G, I will reduce by 1. I have to reduce this normal time by 1 for activity G. So I will take this 26 to 25. Now next, if we observe, activity G is present in above 2 rows. So because G is getting reduced, so here is 21 and here is 24. Now how to cross check this, that we have made changes in above two rows are correct. Now in the diagram also for activity G, we have to reduce this normal time from 12 to 11. Now if we observe, if we take the first path A to G, then here is 10 and here is 11, because this is the value after crashing. So 10 plus 11, that is 21. So we have taken. Then for BCG, so here is BCG, 8 plus 5 plus 11. So 8 plus 5 plus 11, that is 24. So in this way we have to reduce for this activity G if it is present in other rows also. Now we will move next. So here what is the crashing cost? So if we reduce one activity by 1 week, then here this crashing cost, that will be 250. So we have to make changes here. So what is the total cost? That is 71,250. Now what is the indirect cost? That is 2800 multiplied by 25. That is 70,000. So this 70,000 plus 71,250. So I will make here calculation. Here is 250. Then 70 plus 71. Here is 1,41,250. So this cost is getting reduced. Now again we will move next. So same, how to find out this crashing. So which path we have to select for crashing. So here is 21, 24, 25, 21. So I will select this BDG again. Now here is the less or minimum value 250. So I will select this 250. But we have to consider the previous cost also, that is 250 plus 250, that is equal to 500. So I have to mention here 500. Now these two are the changes. Third change in this here. So G activity is present. So I will write here 24. Here will be 23. Here will be 20. Now for G activity I will reduce here this time, that is from 11 to 10. Now we will make these calculations later. So in the same way we have to add all these costs. Now we will move next. So next one, again we have to select the activity for maximum normal time. So here is BDG because it is 24. So again I will select BDG. So again for G is having less cost of reduction. So I will select here G. So here for G 250 plus previous cost 500, which is equal to 750. Now for this 750 I have to mention here 750. Then the next change in the diagram I have to mention here this 9, because we have to reduce this time, and here G activity is present, that's why I will reduce this 19, 22, 23. Now again if we observe, this crash time is less than normal time. So again if we compare 19, 22, 23, 21. So 23 is maximum number. So I will select this BDG. So for this BDG, again I will select the same value, that is I will select this activity G for 250 plus 750, and that is equal to 1000. So I have to mention here 1000. Then I have to reduce this activity, that is from 19 to 18, 22 to 21 and 23 to 22. Now in this also I have to make changes from 9 to 8. So now if we observe, we cannot select activity G because normal time is equal to crash time. Now again if we observe, here is 22, 21, 21, 18. Again for this activity normal time is maximum, that is for BDG. So again I will take BDG. Now this G we cannot select because normal time is equal to crash time. So remaining are the two activities B and D. B is having 25,000, D is having 2,000. So we will select this D. So I will mark here D. So for this D is 2,000. plus previous cost is 1000, that is equal to 3000. So this is the crash cost 3000. So I have to select here. Now we have to make the changes. So for this D, so here is activity D is here. So I will make here the changes from 6 to 5. So I will make the changes here also, because D is present only for one row. D is not present in other rows. So I will here make the reduction for this row also, that is from 22 to 21. Now how to select the next activity? So for that we have to compare this normal time 18, 21, 21, 21. So there are three activities which is having maximum normal time. So we will select these three activities B, C, G, B, D, G, B, E, F. Now we know that we cannot select this activity G because normal time and crash time both are same. Now if we consider this activity B, because B is common in these three activities, then we have to reduce this cost of reduction for only one time. But we have to compare this. So what is the cost of reduction for this activity B? It is 2500. So I will write here 2500. Now if we select the other activities, so here we cannot select G. So for activity C, it is 6000, plus for activity D, it is 2000, plus now in between E and F we have to select. So here E is having 2000. So we will select this E. So if we add this, then it is equal to 10,000. Now we have to compare this 10,000 and 2,500. So this 2,500 is less than 10,000. So we will select here the activity B. So I will mark here activity B, and B is having 2,500 plus previous 3,000, which is equal to 5,500. So we will mention this cost here. Now we have to make the changes in this table and in this diagram. So for activity B, we have to reduce this from 8 to 7. And here B is present in these three rows. So from 21 to 20, 21 to 20 and 21 to 20. Now again we will move for the next crashing activities. So these three activities are repeated and is having maximum normal time. So we will say B, C, G, B, D, G, B, E, F. Now if we compare this, B is having normal time greater than crash time. So again we will select the same activity, because if we select the remaining activity C, D, E, then the same 10,000 cost of reduction. So I will select here B. So for this B it is 2,500 plus previous 5,500, which is equal to 8,000. So I have to write here that's 8,000. This is the crash cost. So for this B I will reduce with 1, that is 6. Now this time B is having the normal time is equal to crash time. And now for this B we will consider here as a 19, 19 and 19. Now we will move for the next. So again we have to select the activity. So same process is there, because this 19 is the maximum number. So three activities B, C, G, B, D, G, B, E, F. Now this time we cannot select B because normal time is equal to crash time. Now this time we cannot select G also. Now we have to compare this C, D. So there is no option. So we will take this C with 6,000, D with 2,000, and in between E and F we will select E because of 2,000. So total is 10,000 plus previous 8,000, that is equal to 18,000. So we will mention here 18,000. Now we will reduce these activities C, D, E. So I will mark here C, D, E. So C will reduce from 5 to 4. Then D will reduce from 5 to 4 and E will reduce from 8 to 7. Now here also we have to make changes 18, 18 and 18. Now if we observe for each various possible path, normal time is 18. Now in this table we have to add this normal cost and crash cost. Here is the total cost. Then we have to calculate indirect cost by multiplying these weeks to 24-23 with this 2800, and then we will find out the total cost. Here is the calculated total cost. If we compare all this cost, here is 1,43,800, 1,41,250, 1,38,500, 1,36,150, 1,33,600. So this cost is getting reduced. 1,32,800, 1,32,500, 1,32,200, but at the last 1,39,400. Now which is the minimum total cost? So minimum total cost is this. So I will make the bracket for this entire block. Now from this we can say that we can reduce the project time up to 19 weeks with minimum cost 1,32,200. So what is the best possible time for the completion of project? That is for 19 weeks, and this will make us, that is the minimum cost of the project, that is equal to 1,32,200 rupees.